Hey everybody, I'm gonna do some more homework answer keys. So I'm gonna do all three. So week 12, 1 and 2, week 13, day 1. Um, I don't know that I'm gonna go back and do the lessons because I think you guys can learn everything you need from the homework walkthroughs. I will talk, I won't just do the problems. I'll definitely talk about, how to do them and why I'm doing them. So that might be all I do. If you need more, just let me know. Anyway, um, here's those classroom notes from day 1. I'm just going to blast through all that, take you to the first homework assignment. Um, so I've already done this one problem, so maybe I won't do it again just to save some time. But basically it says use the law of cosines to answer the following. Also use Heron's formula to find the area of the triangle for problems 1 and 2. So looking here for number 1, you can see that your given information is a side, and a side. And anytime you have side, 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 you know you have to use law of cosines. Even if the paper didn't say law of cosines on it, if this was mixed review, you would know that with side, 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 your only option is to use law of cosines. Same with side, angle, side. If you have side, angle, side, you have to use law of cosines. There's no way around it. So looking here, we're doing c squared equals a squared plus b squared minus 2 times a times b times the cosine of c. And then you'll notice, well, I'm not actually doing the cosine of c, I'm doing the cosine of a. So why? Well, because it said find the measure of the largest angle. And we know that the largest angle will always be opposite from the side that is the longest. So that's for us a. And we know that the way this equation works is angle C and side C, the one that's in this position, the one that's all alone on the left, that side has to be the side that's opposite from this angle. So if we're trying to solve for angle A, then of course this has to be angle A here in the cosine function, but that means side A has to go here. So we're not really using this formula exactly. It would be more like the A, and this would be B and C. But I told you not to bother memorizing these sort of alternate forms because you just want to memorize that relationship, okay? But anyway, that's why you see me plugging in 192, 173, 59, minus 2 times 173, 59 cosine A. So square this, you get this number. Square this and square that and add them up. I'm doing this part, I'm doing all of that to get this. Then I am multiplying out this coefficient to get this. But now cosine A, that's like a variable expression. We want to solve for that. So to get cosine A alone, you can't subtract the 20,000 from the 33,000. They're unlike terms because this is attached to a variable and this isn't. So instead what we have to do is subtract the 33,000. That leaves us with 3,454. Then you divide it by this number. This essentially becomes the coefficient on your variable. So you then divide by that. That gives you this fraction. And then to get to the answer, geez, I'm really not showing work. I wonder if you guys could hang with this level of work being shown. I hope most of you could, but how did I get from here to here? All I did was draw an arrow. We applied inverse cosine, right? You have to take the inverse cosine of both sides. So I'm doing the inverse cosine of that big old fraction, 3454 over 20,414. And that's how you get A. Do the inverse cosine of that. I'm getting 99.741. Anyway, once I've got that angle, I want to find the area. And we said you have to use Heron's formula. So for Heron's formula, you need the semi-perimeter because Heron's formula says that the area will be the square root of the semi-perimeter times the difference between the semi-perimeter and all the sides. So you do S minus A, you do S minus B, you do S minus C. And you take that big product of those four things and take the square root of that. So to find the semi-perimeter, you find the perimeter and chop it in half. So you're adding all the sides, dividing by 2. I'm getting 212. So that means I want the semi-perimeter itself, and then I want the difference between the semi-perimeter and all the sides. So this 20 must be the 212 minus the 192. That's 20. Then you do the 212 minus the 173. That's 39. Then you do the 212 minus the 59. That's the 153. Now, if you multiply those four numbers together, you'll get some really big number. And then you'll take the square root of that, and you'll get a smaller number, still kind of a big one. You get to 5,029.918 square units. It's area, so you give me square units. But that's it. That's how you do number one. And number two is very much the same, but we'll do it together. I lied. It's not the same. Number one was side, side, side. And looking at number two, we can see that it's actually a side and an angle, which if you look at it, SSA, if you reverse that, that's ASS. And by now we've talked about the ambiguous case and how when you have ASS, you could potentially get more than one answer. But this is not actually ASS, because draw this out. And you've got your angle A, which is 161.9. And then across from angle A would be side A. You don't have side A. You've got side B and C. So you could put those on either side. And so we actually see that when the two sides you're given with the angle both have names that are different from the name of the angle, it means they must be on either side of that angle. So that angle is an included angle. So it's not ASS, it's SAS. And SAS again is one of those sets of information that will always lead to exactly one unique solution. So you don't have to worry about this being the ambiguous case. By the way, I'm aware my drawing is garbage. The 161 will be this big obtuse angle anyway, 161.9. And the only reason that's worth mentioning is because you now know that 17.9, I mean 12.1. They're asking you to find the length of A. You can see that A is going to be significantly longer than either of the other two sides because that angle is obtuse. It's so wide. You should be expecting a much bigger length than either of these, maybe 2 or 3 times bigger. So don't freak out if that happens. Anyway, let's get down to business. It's SAS, so I know I still have to use the law of cosines. I'm going to write it out because I just think the more you write it, the more likely you are to remember it. So c squared equals a squared plus b squared minus 2 times a times b times the cosine of c. And again, I don't really pay attention to these letters at all. Again, the idea is I'm trying to solve for a, and I've got angle a. So I know that if the only angle I have is angle a, then I'm plugging in the 161.9 here. And then the side opposite from this angle is a. So this is not really going to be c, it's going to be a for us. And then the other two sides are the other two sides, the 17.9 squared, 12.1 squared, minus 2 times 17.9 times 12.1. So there's our big equation. So the good news is everything over here is just evaluatable. We just do it all. I think just for good measure, though, I'm still going to go ahead and continue thinking about these things as sort of being separate from one another. And just to do this in steps, let's square those values and add them up just to see what we get. 17.9 squared plus 12.1 squared, 466.82. And then we can just multiply this whole thing out and see what we get. So 2 times 17.9 times 12.1 times cosine 161.9 negative 411.744. Now I'm going to write 744, but it's really 7444046, and it goes on and on and on forever, right? So maybe I'll put like a dot, 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 indicating that I'm going to use that whole decimal. So in the next step here, you know that subtracting a negative will go to plus. So I'm really adding. So in my calculator, I've got this negative. You know, let me pull up the calculator. I want to show you guys all these keystrokes. Yes, I'm going to do it now. Bear with me. Just fast forward because this is going to take me a second. You know what? Let me pause. And then you won't notice how long it takes. Okay, so I'm cut back up. Now I have to remember to actually share the calculator. And then I have to remember to go back and share the flip chart. We'll see if I do. Not typically good at that. Anyway, so what do you do from here as far as just using your calculator efficiently? You got 2 choices. Whoa, that's a lot of light. That much light will do. If you've got a new calculator, then you guys can actually scroll up like this and sort of highlight the work or highlight the answer. So this might be the easiest thing, is highlight that number, say enter, then say minus, highlight the next one, say enter, and now you've got it. You're doing the 466 blah, 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 minus the negative, you hit enter, you get your answer, okay? So that's cool. We could certainly do that. But if you have a lower tech calculator, then you might have to do this. Imagine you've done this work, gotten that answer. Then you did this work and got that answer. Then one thing you might do is you know you want to add these two things. So just take the answer you've got, multiply it by -1, just to get it back to positive, and then add to it. You can type in the other one, 466.82, enter. And again, maybe I'm telling you stuff you already know, but I do find that students have not thought this stuff through all the way. A lot of times when I tell them some of these calculator tricks, they're shocked and they did not know them. So forgive me if you already knew it, and I'm telling you something you already knew. But hopefully that's helpful to somebody. Anyway, let's take that 878.564 and carry that over. So we just found out that a squared, green. I don't have it on this calculator. All right, 878.564. And of course, it's not really 564. It's 564, blah, 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 blah. So again, I'll put, you don't have to ever put a dot, dot, dot. I'm putting it to remind you that I'm using the full value of this decimal. So you take the square root and you'll get an answer. So how do you do the square root? Well, again, go back to the calculator. One of your best friends in this unit is going to be knowing that you can get your previous answer. You go second answer. And so now instead of using a rounded off decimal, you're using this thing here. And you're not even just using, you're not using what you see here. This thing extends much further in the calculator's memory. So you're getting a much more precise answer when you do this. So make sure you do that. So 29.641 is going to be the answer. I'm writing that down. You can't see me doing it, but I am doing it. 29.641. So why am I being so adamant that you use the answer thing? Well, what if I tried to take the square root and I just typed in the 878.564? This may come out okay. Actually, yeah, okay. This is not the best example, but there are certainly times when, even if you use 3 decimal places, you get an answer that's kind of significantly off from what you would have gotten if you use all the decimal places. Square roots, I guess, are a little more forgiving, but the big one is inverse trig, okay? So for example, I don't know, 125 divided by 2,547. Imagine if you had this decimal. If I do the inverse sign of that decimal to get some answer, I get that. What if I do the inverse sign, though, of just rounding this off, 0.049? I'm off by kind of quite a bit here, right? I would be expecting you to say 2.813. You'd be saying 2.808. You're off by 5 thousandths, and I expect you to be off by no thousandths. So you can see where there is kind of a difference there. Okay. Anyway, I'll shut up about calculator tricks. I'll shut up about accuracy, and I'll just get back down to business. Here we go. What am I doing? Share. Oh, yeah, that's what I want. Okay, so back to the homework. We've got our answer. The length of side A is 29.641. But we also need the area. So we're supposed to use Heron's formula. There is another formula that we learned for when you have side angle side. And so there's probably a better way to do this one with the information that we were given. We would probably want to use the side angle side formula, but the directions specifically said use Heron's formula because we want you to get that practice. So using Heron's formula, we need to find that semi-perimeter first. So take your sides, 17.9 and your 12.1, and the side you just found, 29.641. Add them all up, chop it in half. Let's see what that gives you. So I'm adding 17.9 and 12.1, chopping that in half. So 29.820. That's your semi-perimeter. So that means your area is going to be that semi-perimeter. Multiplied by the difference with all the other stuff. So again, I want to take you back to the calculator and show you something one more time that I've already shown you, and hopefully you'll remember, but clear this garbage. So we got the 29.841, 820. All right, you're about to have to type this over and over and over again, right? So a good shortcut is storing this. Remember the store button? I can store this as the variable x, which is just a quick single keystroke. So now it's in there. So now when I want to do that thing minus, I can actually just hit x minus 17.9. And again, it's not too hard to type 29.82, but if you had a sort of a longer number, a bigger value, and you didn't want to have to keep keying it in over and over again, storing it as x is kind of a nice trick. But I see that I want 11.2, 11.92. I also want x minus the 12.1. So do that subtraction. And then I also want x minus our other side. That's a plus, minus. Our other side, which is 29.641. But there's the other three numbers that we're going to want under the radical in Heron's formula. And I calculated them quickly by just being able to press X instead. So that's another good little trick. Back to the work we go. I can now grab these numbers and enter them. So we had 11.92, which is technically 920. We had 17.72, 0, and then we had 0.179. So now you got to multiply all that together and find out what the square root of the result is. So on my calculator, I guess I'm typing all that in. I don't really want to. 11.92 times 17.72 times 0.179 times the semi-perimeter, 29.820. So that product is 1127.458702. So you'll take the square root of that. What am I sharing? My screen? Great. So back to the calculator for a quick second. A great way to take the square root that I haven't showed you guys is, instead of having to hit like second radical, second answer, let me just do it. Second radical, second answer. It's not like that takes a long time, but if you've already got this number here in your calculator waiting for you, then just hit caret and 0.5, because I'm raising it to the 1/2. That's square root, right? That to me always feels a little shorter. So that's kind of my preferred method for getting square roots out of my calculator. You could take that. That's yours. That's free gift from me to you. I think it's better. You do what you want though. Here we go. So I'm getting 33.578. Boink. So there, we used Heron's formula to get that area. Moving on. So number 3, it says a surveyor finds that the angle at point C is 72 degrees. So right away, I don't care for this drawing. I'm probably just going to redraw this. What we've got is a triangle. There's a 72-degree angle up there. It says AC is 15. AC is just this side over here. It says BC is 21. That's this side over here. So it says find the length of AB to the nearest tenth of a meter. So AB here is this. Call it X. I don't really need any of this context about this survey. I don't even know what the surveyor would be doing. The surveyor could just calculate this distance with a damn tape measure. I don't know what's happening here. Normally in these problems, you would probably find like this distance because it's kind of hard to measure distance across a body of water. This one seems silly to me, but that's okay. Let's solve this one. We can see that it is side, angle, side. So we got to use law of cosines. It's going to be the same as all the ones we've done before. So we know that we're solving for x. So we'll go x squared equals, it'll be the 15 squared plus 21 squared minus 2 times 15 times 21 times the cosine of 72. Okay, great. So we got to do this in our calculator. And at this point, you know, you can just put this whole shebang into your calculator all at once. It's not like, you know, it's not like it's going to be wrong. So I'm going to do that. 15 squared plus 21 squared minus 2 times 15 times 21 times cosine 72. Did I type it all correctly? Looks like I did. So I get 471.319. But again, it's 3192935. So blah, blah, blah. This goes on and on. Take the square root. So again, I'm going to just raise this thing to the power of 0.5. That's my square root in trig. I'm getting 21.710. And that's because I'm getting 21.7098. So that 8 says round me up. But rounding a 9 up turns it into a 10. So you get a 0, you carry the 1, you get that. Forgive me for mentioning that, but I've seen people do crazy things rounding off numbers, especially when 9s turn into 10s. Anyhow, there's your answer. This is a real world based word problem, so you better give me units. And there's units right here. You're being told these are meters, so this is also meters. Moving on. Number 4, you're given parallelogram ABCD with these dimensions. So it says find the length of the two diagonals. So you might notice that if you take one diagonal at a time, you're really just working on a triangle. So if you wanted to find the length of diagonal AC, you might just sort of consider pulling out triangle ADC. And when it comes time to find the length of diagonal BD, just consider pulling out triangle BCD. And think about it like that. So we know that in this triangle, we're trying to solve for AC. I'll call it X. We were given that AB is 17. Well, AB is up here, but of course in parallelograms, the opposite sides are the same. So if that's 17, this is 17. So we can label DC down here as 17 and over here as 17. We were told AD is 12. So that means this is 12 and this is 12. So that means AD in this triangle is 12, but BC in this triangle is also 12. And in the green triangle, we're trying to solve for that diagonal BD. We'll call that Y. So right now, I don't have enough information, but they also told us that angle B was 71. So angle B here, that whole thing is 71. But I know that in parallelograms, opposite angles are congruent. So if B is 71, then angle D over here is 71. So now we see that in the red triangle, we have all the information we need. We've got our side angle side, so we can solve for X. What about over here, though? Angle B is being chopped into two parts, like an alpha and a beta. And I don't really know how to break that down. I mean, I do, but I don't want to. It would take a lot of effort. So I'm not doing it. So instead, why don't we maybe just remember that we're a parallelogram? And in a parallelogram, your consecutive angles or adjacent angles are supplementary. So the fact that this guy here is 71 does tell me what this one down here is. It has to be the supplement of it. I'm not going to get too deep into the weeds on that. They're supplementary. So just subtract and you'll get 109. And so that means this is 109. And we can just use that to solve for the other one. So let's do it. We can see our work is cut out for us. We just need to do law of cosines twice. Okay. So in red for this one, we'll be saying that the x squared is equal to the 12 squared plus 17 squared minus 2 times 12 times 17 times the cosine of 71. So again, I'm just mashing the buttons on all of this and getting what I get. 12 squared plus 17 squared. Yeah, hold on. Let me do this in the other calculator so you all can watch. I think I've got a trick up my sleeve that you might appreciate. Clear all this garbage. We're going 17 squared. Well, 12. I'll just do the 12. Y'all know it doesn't matter though. Okay, 12 squared, 17 squared, minus 2 times 12 times 17 times cosine of 71. Enter. I get the 300, and then I can just do the whole raise it to the power of 0.5 thing to get my square root. So there's the answer for the first diagonal. So carry that over back to the thingy. So we got 300 something, which I am writing down just in the interest of showing my work to my teacher. So that's 168. And then I take the square root and I get 17.325. All right, why did I make a big deal about showing you the calculator work? Well, because when we come over here, what are we getting? This time we're getting y squared equals 12 squared plus 17 squared minus 2 times 12 times 17. This is feeling familiar, isn't it? Cosine of 109. Literally the only thing that changed is that cosine. It's 109 now instead of 71. So it sure would be nice if someone taught me how to use my calculator. So back to the calculator we go. I sure wish I could get this expression back so that I could just edit that 71 to a 109. And I taught you this trick already, but most of you guys probably weren't listening or didn't care. But here's the deal. You hit second entry and you get your previous entry, but you can hit second entry again and it'll scroll back in time a while to give you your other previous entries. So now that you've got this thing, it's editable. So if a side length changed or something, you could change it. In our case, the angle measure changed. So we'll turn that 71 into a 109 and we'll get our new value, the 565. And we'll raise that to the power of a half, get our answer. So there, hopefully that trick serves you well. It's something you want to keep in your back pocket. It's pretty useful for saving time. So anyway, we now have the 565.832 technically. And when we take the square root, we get 23.787. So there's your two diagonals. There's your two diagonals. So this thing that I called X is actually diagonal AC. So the measure of segment AC. This thing that we called Y is BD. The measure of segment BD. There you go. Moving on. 5. So a regular pentagon, if you don't remember, is a 5-sided polygon where all the sides are congruent and all of the angles are congruent. That's what regular means. It means you're equilateral and you're also equiangular. And it says it's inscribed in a circle of radius 10. To be inscribed means that all of its vertices fall on the circle. That's what it means to be inscribed. The vertices all lie on the circle. It also says that the circle has a radius of 10. That means our circle must have a center somewhere, probably right about here. And if you were to draw a radius of the circle, You draw that radius to one of the vertices, probably, and that distance is 10. You could draw another radius to another vertex. That's 10. They're asking you to find the length of a side. These things are not being super specific. I mean, the only thing here that has sides is the pentagon, so we know that, but you should probably say find the length of a side of the pentagon to the nearest tenth, never tenth, always thousandth. But that means that what we're solving for is the length of a side. I'm going to call it x. So we're missing something. We know that to solve, we would need an angle. And ideally, the angle that we want is the one that's opposite from x, so that central angle. And it's pretty easy to find, as long as you draw in the other radii. If this wasn't already obvious, I think it becomes obvious that what we've got here is 5 angles that all fit around a single point. So those 5 angles would have to add up to 360, but don't forget that we're regular. So we're talking about all 5 sides being congruent, all 5 angles here are congruent. That does translate to all 5 of these central angles having to be congruent as well. So if we call that central angle theta, then we know that theta would have to be 360 divided by 5, which gives 72. So now we've got that central angle. We've got side angle side. So guess what we have to do now? Yeah, that's right. Law of cosines again. That's what we're doing. Just double checking that I'm sharing the right thing. Okay, so law of cosines one more time says x squared equals. Now it's just going to be 10 squared and 10 squared because the two sides are the same. Then it's going to be minus 2 times a 10 times a 10. And then it's going to be times the cosine of our central angle, which we figured out to be 72. So much of this math I can do in my head. That's 100 and 100, so that's 200. That's 100 times a 2, so that's 200. Cosine 70. 72, yikes. All right, I've run out of math that I can do in my head, but I can type this in a little bit easier. So 200 minus 200 times the cosine of 72 gives us 138. 0.196. Technically, it's 1966011, so dot, dot, dot. Take the square root. You get your answer. So I'm going to raise to the power of 0.5. I get 11.7. 557, so 5.6 as we get to the final answer. So what's it say? We had a radius of 10. There's no unit. It doesn't say centimeters or inches or whatever. So here you'll just say it's 11.756 units because we weren't given any specific units. Are we done? Find the length of a side to the nearest thousandths? Sure. If I wanted to get more interesting, I could ask you, okay, now what's the perimeter? And you'd go, well, it's just this thing times 5. There's 5 of them. So adding them all up, you'd multiply by 5. Is there any other interesting question I could ask? Not really. Moving on. Okay, so this is basically the same question. It says this time that a regular heptagon is inscribed in a circle. Find the length of a side and to the nearest, find the length of a side to the nearest tenth. Oh, is, right. That's a typo where it's supposed to say if the radius of the circle is 17.3. So this is exactly the same question. Just with a heptagon, which is 7-sided instead of a pentagon. Yeah, I thought there was something different. I thought they were going to ask you for this dimension, like the height of these triangles here. But no, they're not asking for that. So we're doing the same exact thing. We're told that the radius of the circle is 17.3. So that means this dimension is 17.3. That's 17.3 as well. I don't know what this says, 51 and 3/7. I don't know, but we know where that comes from. It's 360 divided by 7. So if we do 360 divided by 7, we get 51.429 essentially. Yeah, so this does say 3/7, by the way, but you're never going to use that fraction, I wouldn't think. Maybe you would, who knows. Anyway, we're again solving for the length of the side, so call it x. Man, this is repetitive, but here we go. X squared equals 17.3 squared, 17.3 squared minus 2 times 17.3 times 17.3 times the cosine of 51 3/7 degrees. Sure, I'll use your fraction. All right, do all that math. 17.3 squared plus 17.3 squared minus 2 times 17.3, essentially squared, times the cosine of 51 3/7. I'm just going to type in 360 divided by 7. It's easier. Okay, I'm getting 225. 0.371. And then a whole bunch more. So when I take the square root, I'll take the square root of the whole expansion to get 15.012. And again, no units were given, so you'll just say units. Yeah, that'll do it. Oh, all right, I'm getting tired again. So now we move on to 7 and 8, and 7 and 8 are both real pains in the butts. I was asked about 7 in class by basically everybody, and I talked about it for sure. I guess today I'll really do it. I'll do every little part of it. I don't want to, but fine. So the idea with this problem is we have to find BC. So the way we'll find BC is we'll chop this thing up. Chop, chop, chop. And so by drawing in that line, then we've basically just made a triangle, DAC. I still hate that C is over there. It's such a stupid place for it. Okay, get that C out of here. Put that C there. And so by making that first slice, we basically now are just dealing with this little triangle, triangle DAC, where this side is 24, this side is 44, this angle is 86, and we're trying to solve for segment AC, which I shall call X. So you now do the law of cosines to find it. God, I'm not going to walk you through it. It's just too much, but you guys should understand that that's what we're going to do. So we would say what? X squared equals the 24 squared plus the 44 squared minus 2 times 24 times 44 times the cosine of 86. And I'm just going to go straight to the answer from here. I'm not going to show steps. Okay, I'm back. So this is going to be 2364. 674. That's x squared. So x is actually 48.62 791716 628. So 628 is going to be what it really is. Okay, fine. We figured that out. That means this side right here is 48.628. And that's good because that now seems like I can go find BC like I wanted to. BC here, I guess we had called this X, so we'll call this Y. But I'm not really ready to find y, because even though it looks like I've got a triangle here where I've got side angle side, I've got the 36, I've got the 48, I've got the 110. Well, this isn't 110. 110 goes all the way. So the next little stumbling block was we know that the 110 has been split into two angles. You've got sort of an alpha piece and a beta piece. So actually, to solve for y, we need to know beta. But we can't find beta yet because we don't have information about it. We don't have enough. But if we go back to triangle DAC, we can find alpha because we do have the 24, the 48.628, and the 44. So that means we're going to take a detour before we can solve for y. And we're going to still grab this same triangle, DAC. And this time what we're after is alpha. So we've got the 24. We now have the 48.628. And we have the 44. So this time we have to write another law of cosines equation. We'll say the 44 squared has to go here. And it equals the 24 squared plus the 48.628 squared minus 2 times 24 times 48.628 times the cosine of alpha. So again, to solve this one, we'll do all this out. We'll do out this coefficient and kind of work from there. So there's all this stuff. 44 squared. This one I will walk you through because we haven't done this exact one in a while. So it's 1936. And then 24 squared plus that 48.628. I am just using 48.628. I'm not using the full expansion this time just because I don't want to type it all out. So my answer will be a little less precise, but that's okay. I'm getting 2940.682. And then we're subtracting from that 2 times 24 times 48.628. So 2334.144. And then that's times the cosine of alpha. So we're at that point now where we have to remember that you can't actually subtract these. You have to subtract this from both sides instead. Get that to cancel. So now whatever this is will be equal to negative 2334.1. Those are fours, right? Yeah, 144. My writing tablet just keeps connecting the tops. All right, so what's 1936 minus that thing? 2940.682. And I am rounding off because I just don't care. Negative 1004.682. Oh, I almost forgot. This is times the cosine of alpha. So now we divide by that coefficient. And you can get that to cancel. And so finally we have just the cosine of alpha, and it's going to equal whatever nasty decimal this comes out to be. So divide by negative 2334.149. So I'm getting 0.430427 5348. But again, this is going to be off by a little bit because I was rounding off as I went. But finally, to get your answer, you're going to do the inverse cosine of that 0.430 ... to get alpha. So second inverse cosine of second answer, 64.505 degrees. But that's alpha. and I actually don't want alpha. I really need beta. So let's take alpha, come all the way over here. And of course, to find beta, we're just going to do the 110 minus alpha. And that tells us that beta is 110 minus, second answer, 45.495. Barking dog, be right back. The Terminex man was here. The dog didn't like that. Okay, back to this gigantic problem. We now have B, which means now we can focus our sights on triangle ACB. So this one, A to C to B. And so now the information we have is we've got angle B at 45.495. We know that we want to solve for BC. So that's the thing that I'm calling Y over here. To find it, we'll have to use the thing that we found earlier, the thing that I called X, 48.628. And we'll use the 36. So again, it's sort of just a series of many, God, the dog. Anyway, we can solve from here. Ugh, all right, I believe the dog has been quieted for now. So now to solve, we're doing the same thing we already did. It's exactly the same as, not the purple, it's exactly the same as the green, where we know the two sides, we know the angle. So it's exactly the same way that we solve for X. So much so that I refuse to even show the work. So instead, I'll use my handy dandy calculator program that I just wrote. 48.628, enter. 36, enter. 45.495, enter. The answer is 34.734. 34.734. And so when I say Y, I'm really talking about the measure of side BC. So how to get from there to there? Use law of cosines. And again, sorry, not showing the work. It's the exact same as the green work up above for X. And we're still not even close to done because we just found the first thing they wanted, and they still want angle B and they still want angle C. So, all right, angle B and angle C, bring that down. At least we know that we're stuck in this triangle still. Here's angle B. I now know side Y. So the good news is we've got all three sides, which means we can find angle B, we can find angle C. Again, it's by using law of cosines. Now this time, to solve for angle B, the work will be like the purple, where the angle measure is our variable. So my handy dandy program doesn't solve that kind of problem. So I'll set it up for you, and then I'll just kind of solve it and give you the answer. But you know what to do. You know that to solve for angle B, we would take side B, the 48.628. We'd square it, we'd set it equal to the other two sides, the 36 squared plus the 34.734 squared. Would subtract from it 2 times 36 times 34.734. And then multiply by the cosine of B. So you'd be hitting the buttons to solve, solve, solve. I'm going to solve it off camera and just give you the answer. Okay, I'm back. And I wrote a new program for solving this type of equation. So let's run it. Enter the 48.628. Enter the 36. Enter the 34.734. According to my program, the measure of angle B is going to be 86.842. Okay, and I'd love to say we're done, but we're not. Because in addition to B, angle B over here, we are also being asked to solve for angle C. Luckily for us, solving for angle C is a piece of cake because we've already got, well, this is annoying, but we've got angle beta and we've got angle B, and we know that beta plus B plus C would have to be the full 180. So to find C, we can just do 180 minus the sum of these other two guys. So let's do that. Where's beta? Where's beta? Oh, beta's chilling right here. Okay, so here's beta, and here's B. So we know that the measure of angle C is just going to be 180 minus beta, 45.495. Plus 86.842. And forgive this thing for making every 4 look like a 9. All right. So we can do 180 minus the previous angle plus 45.495. I'm getting 47.663. Okay, so this was a super nightmare of a problem, but we're through it. You were asked to find B and C, and you were also asked to find the measure of BC. So we found those three things, and just notice that along the way, how much we had to do, right? We had to find this diagonal, the red diagonal called X. We found it. We had to find angle alpha so that we could find angle beta. Once we had angle beta, that allowed us to find side BC. Side BC allowed us to find angle B and angle C. So we're done, and I showed all my work. So can I even fit all my work on the screen at the same time? Barely. That's a lot of work, and I didn't even show all the work either, but hopefully you guys understand the gist of it. Moving on to the next hard one. This one, which actually isn't bad. Let's do it. Best fit. All right. So we read it. It says the radial range of two planes is 320 kilometers. The planes leave an airport at the same time on the courses indicated in the figure. Find to the nearest minute the time after takeoff that the planes will lose radio contact. It's been brought to my attention that some people were interpreting this question to mean when the planes will lose radio contact with the airport. So if this is sort of the airport, and this is plane X, and this is plane Y, some people were just interpreting when will the distance from A to X exceed 320? When will the distance from A to Y exceed 320? Well, since they're moving at different rates of speed, X would exit the radio range sooner, have a shorter time. This would have a longer time. You'd have two different answers. That's just not what we're going for. What we're actually going for is when will this distance between plane X and Y exceed 320? So we're supposed to be interpreting this as when will the planes lose radio contact with each other? And so the idea here is, well, here's our little headings that the planes are flying on. Plane X was flying in a direction. This dotted line, by the way, is supposed to be north. That should really probably be labeled. But if that dotted line represents due north, then we've rotated 43 degrees east of due north. But the other plane is rotated 87 degrees east of due north. So, the actual angle that we need is this guy here, which would just be the 87 degrees minus the 43 degrees for 44 degrees. So far, if we're sort of redrawing this triangle, we know that we're looking for when this side becomes 320. We know that this is a 44-degree angle. What we don't actually know is the length of this side, because we don't know how much time will go by before this side grows to a distance of 320. But that's fine, because we're solving for time, and if time is in hours, then won't this side be modeled by 236 times time? Rate times time equals distance, right? So the length of this side would be the speed of the plane times the amount of time that's gone by. Same thing down here. It'd be 142 times time. So this problem is a little bit different, where you've got all three sides, you've got the angle. There's just a variable in the length of the sides that we're solving for. So we can set this equation up algebraically. We know that we'll use the 320 over here, say 320 squared. It'll have to be equal to the 236t all squared plus 142t all squared minus 2 times 236 t times 142 t times the cosine of 44. Okay, so to be smart about this, this is going to give us a t squared, this will give us a t squared, and a t times a t is going to be a t squared. So something you might want to do right away is factor out that t squared. And then you can do the 320 squared. Oh, these numbers are just so big all the time. 320 squared. Oh god, 102,400. If I factor out that t squared, then now I just have to do the 236 squared. So 55,696 plus 142 squared, 20,164. I don't know why I'm doing this so slowly. We can just do all this in our calculator at the same time, right? But then we would get minus all this mess. So 2 times 236 times 142 times cosine 44. I'm getting that to be 48,213.08078. Sorry, 03078. Oh no. Okay, 030,878. 030,078. There's no 8 here. It's just 03078. Okay. But so that's going to be the 102,400 t squared. And then just figure out what all that garbage is. So 236 squared. Cosine 44. So that was 27,646. 0.96922. So now divide both sides by that. You'll get some decimal. .703. .417. Again, whatever. This decimal goes on and on. But that equals t squared. So just take the square root now, and you're done. 1.924. 536. These are hours. And you weren't asked to solve in hours. You were asked to solve in minutes. So multiply this by 60. That'll convert it to minutes. So that's minutes. So they said find your answer to the nearest minute. Well, 115 is more than an hour. So I would subtract 60 from that now and call that an hour. And then if you subtract 60 from this, you're left with 55 more minutes. And the 0.472, you'd round that down because we're rounding to the nearest minute. So it'd be 1 hour, 55 minutes. And so that's telling you that just about 2 hours into their trip, the distance between the two planes would grow to be more than 320. That's when they would lose radio contact with one another. That is that problem. That is this homework. This homework was a long one. All right, I'll see you. Bye.